And I just typed it in all at once, all right, like this. 1/3 inverse sine of 3/6, which I knew reduced to 1/2, but minus 1/3 inverse sine of 0. Okay, 3 times 0 is 0. Again, it would be silly for us, if this were a test, to not go ahead and just remember that you're typing it in before you integrate it. So 1 divided by the square root of 1 minus 9x squared, okay, comma x, you got to tell it the variable, as silly as that seems, from 0, which is the lower limit, to 1/6, which is the upper limit, okay, and it does confirm that I'm right.
Do you have the gradients for that?
Yes. Yep. Okay. All right. Number 15. New objective. We're just going to do a couple from here today. Use the derivative to determine whether the function, this one, is strictly monotonic on its entire domain and therefore has an inverse function. Show your work. Now remember, the idea behind strictly monotonic is that the function needs to pass the vertical line test and the horizontal line test. All right? And then that's when we'll know. Okay? But we need to show that with calculus, and calculus involves derivatives. So we are going to find the derivative of this thing. So the derivative of the natural log of something is 1 over that something, right? Times the derivative of that part, which is 2x. Again, some people would write that as 2x over x squared minus 3. And that would be fine, not reducible. Okay. Now we do want to find out when this thing is undefined or 0. Okay, so decide if this fraction is ever undefined, and if so, where is it undefined? Decide if that's ever undefined. So functions can't be 0 on the bottom. You can't divide by 0. So this function is going to be undefined at, I just set the denominator equal to 0 and did a quick solve. Some of you probably did that in your head. So it's going to be undefined at negative the square root of 3. I'm going to go ahead and do this here a minute. Negative the square root of 3, or about negative 1.73. It's going to be undefined. And at positive the square root of 3. Okay. And then it could equal 0 too, and a fraction only equals 0 when? Yes, they all said together when the top equals 0. And so the top equals 0 when? When x is 0. Okay. So right between these would be where that is, and there's a 0 there. Now, what it looks like is we have 1, 2, 3, 4 areas to test. But I'm going to tell you that these two we really don't have to worry about. And it comes from this. What happens, or what kind of numbers can you take natural logs of? Decide with the people around you, what kind of numbers can you take natural logs of? I'm sorry, I said that wrong. There are two areas we don't have to worry about, but they are not these two, all right? They are different areas than that. So, but answer that question for me. What kind of numbers can you take logs of? Positive numbers and 0. You can take the natural log of 0, okay? So what happens is, try this for me. Let's see. Between 0 and the square root of 3 would be 1, right? Plug that into this function a minute. See if you can find the natural log of that. Again, try to find this function evaluated at 1. And your calculator says, no, I can't, right? All right. So these two spots, okay, actually this whole middle part, okay, doesn't even exist for our function. So that's where function knowledge is really important, knowing that you can only take the natural log of non-negative numbers, and I can't even plug 0 in there because I get the natural log of -3, which I can't do, okay? So really, I just have to test over here and over here, okay? To test over here, let's plug in something like -2 to my derivative. Remember, we're plugging that into the derivative. And let's plug in +2 over here. Okay? So decide what's going on in those two sections. So when you plug a negative in here, all right, or -2 in there, don't you get a negative on top and a positive on the bottom? So that would be negative. Okay. When you plug +2 in there, you get a positive on top and a positive on the bottom, which would be positive. Okay. And that is not monotonic. Again, to be monotonic, it has to either be always increasing or always decreasing. So the answer to the question is the function is not monotonic. So its inverse is not a function. Okay. Again, just calculus supporting the whole one-to-one thing. This, by the way, I just graphed the original function. This is what it looks like. Okay. It itself is a function. It certainly would pass the vertical line test, but is it passing the horizontal line test? It's not. All right. And that's all we confirmed with calculus. All right, last one for today, number 16, says find the derivative of the inverse at A. All right, find the derivative of the inverse at A. Well, we need to find the inverse then. Tell the person next to you, how do you find the inverse of a function? And I hope you said you switch x and y. So this is normally y equals this business. Okay, we've got to write it like this. X equals 2 minus 3. Now instead of writing this over y squared, how can I write y so it's not on the bottom? Yeah. Okay. Now again, we want this derivative, so we want to differentiate this thing. And we don't have to solve it for y to do that because we know how to differentiate implicitly. So we're going to go ahead and differentiate implicitly. The derivative of x with respect to x is 1. What's the derivative of 2 with respect to any letter? 0. Okay. And the derivative of this term, -3y to the -2nd with